This is video tutorial number 8 for solution stoichiometry. Example question: when aqueous solutions of sodium sulfate and lead 2 nitrate are mixed, a precipitate forms. Calculate the mass of precipitate formed when 1.25 liters of 0.0500 molar lead 2 nitrate and 2 liters of 0.0250 molar sodium sulfate are mixed. So in order to solve a problem like this, the first thing that we're going to need to do is find a net ionic equation. Once we have our net ionic equation, we can look at the molarities and the volumes given to find the moles of reactants and possible moles of product that those reactants can form. We'll use that to find the limiting reactant or limiting reagent and the theoretical yield. Remember, the limiting reagent is the one that produces the least possible amount of product. Once we've done that, we're going to use the theoretical yield to find the possible mass for the precipitate. And again, we're going to do this with the one that makes the least number of moles of precipitate. So if we want to do step 1 to do our net ionic equation, I'm looking at this, and sodium sulfate is going to be Na is +1 and SO4 is -2. We're actually going to keep this in ion form. We're not even going to go to the complete equation because it didn't ask for it. That's just actually going to give us some extra steps if we do that way. Sodium sulfate, and the other one was lead 2 nitrate. Remember that 2 in parentheses means that lead has a +2 charge and nitrate is a -1. So as I look at this, I do my inners with my outers. My PB goes in front of SO4. My Na goes in front of my NO3. The PB with the SO4 has no group 1 metal, no nitrate, no ammonium, so we're going to write that as our precipitate. And since the PB is a +2 and the SO4 is a -2, when we crisscross and drop the signs, that actually becomes PbSO4. And the nitrate with the sodium actually stay soluble because it's nitrate, which we said was one of the ones that's always soluble, and sodium is a group 1 metal. So our net ionic equation is going to be Pb +2 aqueous plus SO4 -2 aqueous yields Pb SO4 solid. So if we can figure out how many moles of lead are in our lead 2 nitrate solution and how many moles of sulfate are in our sodium sulfate solution, we can get to the part where we find the theoretical yield. So, determining the number of moles of reactants. In order to do that, we're going to take our molarity information, and remember, if we multiply volume times the molarity, that gives us the number of moles. And that tells us we have 0.0625 moles of Pb NO32, but we wanted the moles of Pb, and there happens to be 1 mole of Pb +2 for every 1 mole of Pb NO32, because it's in a 1-to-1 ratio, it has a subscript here of 1, so this also means that it's 0.0625 moles of Pb +2 in our first solution. Our second solution was 2.00 liters of 0.0250 molar Na2SO4, and that gives us 0.0500 moles of Na2SO4, and we want moles of SO4, and there happens to be 1 mole of SO4 in every 1 mole of Na2SO4, so this actually winds up also being 0.0500 moles of SO4 -2. And what we want to do with these two numbers is look and see how many moles of product each one of those can produce. So if I take my moles of Pb and I compare that to the balanced equation. Some of you might be looking at the balanced net ionic equation and just saying, well, 1 Pb makes 1 PbSO4, 1 SO4 makes 1 PbSO4, so whichever one of these we put less of is our limiting reagent. But for those of you who can't see that, I'm going to do it the way we've done it so far, which is with the dimensional analysis, just to make sure that we're all on the same page. So, number of moles of lead in. Then we take the coefficients from the balanced equation, and it was 1 in front of the PbSO4. It was a 1 in front of the Pb plus 2, so now my moles of Pb plus 2 cancel. And this one has a theoretical yield of 0.0625 moles PbSO4. That is if the SO4 doesn't run out first. So let's do the same thing. This is how many moles of SO4 we're putting in. And now if we use, again, the coefficients from the balanced equation, the coefficient of PbSO4 is a 1. The coefficient of SO4 minus 2 is also a 1. So really, our SO4 is our limiting reagent because it can only produce 0.05 moles of PbSO4, whereas the other one, the Pb plus 2 moles in, we're able to produce 0.0625 moles of PbSO4. And now what we do is add up our gram formula mass, and our gram formula mass for PbSO4 happens to be 303.3 grams. And now if we take that number and we multiply it by the number of moles, right, because number of moles over 1 times 303.3 grams for 1 mole of PbSO4, we wind up with a theoretical yield, our maximum mass of precipitate that can be formed, which was 15.2 grams of PbSO4.